Hello everyone, today we're gonna talk about Poisson's ratio. In the previous video about Young's modulus, I told you that if we have an object like this and we pull it in this direction, this object will deform to be like this. Basically, it is getting longer in the direction where the force is applied. But to be honest, I wasn't telling you the whole story because in reality, there are many objects that doesn't deform like this. It is deformed like this. If we pull it to this direction, let's say x direction, because this is the x-axis and this is the y-axis, the object will change the shape to be like this. So it's not just getting longer in x direction, it changed from x1 to x2, and the x2 is greater than the x1, but this object is also getting thinner. The length in y direction changed from y1 to y2. In the previous video, I also told you that there is a term called strain that is defined by the length difference over the initial length. So this object has two strains, that is strain in x direction and strain in y direction. The strain in x direction is equal to the length difference in x direction, so x2 minus x1, x2 minus x1 over the initial length, which is x1. And the strain in y direction is y2 minus y1 over y1. Now, we can define a new ratio, that is Poisson's ratio basically. It's usually written in nu. Poisson's ratio on an object that is given a force in x direction and have a deformation in y direction, so nu xy is equal to the negative of strain in y direction over the strain in x direction. This ratio helps us to predict how the object deforms, just like the Young's modulus, right? Like, let's take an example of the object we have talked before. This object has x2, x2 that is greater than the x1. So the strain in x direction is positive, but the length in y direction is getting smaller. So y1 is larger than the y2. That will give us a negative strain in y direction. And negative times negative, as you know, is positive. So this kind of object has a positive Poisson's ratio. You may be asked, is there any object that has a negative Poisson's ratio? And the answer is yes. There are some objects that have negative Poisson's ratio. As you can imagine, for the object with negative Poisson's ratio, if we pull it to this direction, okay, it's getting longer again in this direction, but it's also getting thicker, like this. The example of this object is parenchyma tissue. Parenchyma tissue. It is a kind of tissue in a plant that has spaces inside, like air cavities. So basically this tissue is like a sponge. This object has a unique mechanical properties that is symbolized as negative Poisson's ratio. We also can apply this Poisson's ratio in object in 3 dimensions. Let's say this box, I draw it bigger, and sorry for the very bad drawing. Let's say this is the x-axis, this is the y-axis, and this is, oops, I hope you can imagine, this is the z-axis, this vertical axis. If we give it a force in x direction, fx, here, it will deform like this. Okay, so it's getting longer, but also getting thinner. Here. We can define each of the length, like the object has first x1 change to x2, and then it has this, the z1, it changed into z2, and then the length in y direction changed from y1 into y2. Okay, you can imagine from the front side it changed from this shape into like this, and from the top view we also can imagine the same. The shape will change from this to this. Right? This kind of object has 3 strains. There is strain in x direction, which is equal to x2 minus x1 over x1, and then strain in y direction, that is equal to y2 minus y1 over y1, and strain in z direction, that is z2 minus z1 over the z1. Because we have 3 strains, we can define 2 Poisson's ratio. The first one is nu in x, y. So it is a Poisson's ratio of an object that is given a force in x direction but has a strain in y direction. It is equal to negative strain in y direction over strain in x direction. The second Poisson's ratio is nu xz. That is equal to negative strain in z direction over strain in x direction. Remember that even though we talked about the deformation because of tensile strength, I remind you again, the tensile force, it's this direction. This can also be applied for object that subjected to compression force. Okay, you can try to analyze yourself how the object will change and how's the Poisson's ratio of an object with this kind of force. I think that's all, and thank you for watching. We're gonna see you in the next video. Bye.